Hello, welcome back to this channel. Now today's lesson will be on heat energy, and I will assume that you have some knowledge of this before you proceed to watch this video. Hi, I'm Mr. Long and I will be your science teacher today to go through this lesson with you. Let's get started. Now the first part to revise is on good and poor conductors of heat. Now let's take a look at this picture, this diagram of a kettle. And you're asked to find out which are poor conductors of heat. Now, this is a very straightforward question. The way to think about this is always to think about the functions. Right? What are the functions of the product? Whether something should be made of a good or poor conductors always depend on its function. So for example, part D should be made of a good conductor of heat. So allows it to gain heat faster to boil the water quickly. But they're looking for poor conductors of heat. So think about the function of the parts A, B, C, and D, and which of these parts needs to be made of poor conductors of heat. Now clearly, A is the handle of the kettle, and to avoid getting scalded, a person got to hold on to an object, to a material that will slow down the rate of heat transfer from the hot water to the hand. Likewise, B is the handle of the lid. For a person to hold it safely, this must be made of a material that will slow down the rate of heat transfer from the hot object, like the hot kettle, to the fingers. So the answer to this will be A and B. Now, such question commonly test you using everyday objects. For example, this is a page taken from your textbook. Now, whether you're in P5 or P6, you should always still read out your P3 and P4 textbooks once in a while to recall and to remember the ideas and the things that are taught inside. So this part, for example, is supposed to be made of a poor conductor of heat, whereas this portion must be made of a good conductor of heat. Do also know the kind of materials that are commonly good or poor conductors of heat. Typically, metals are good conductors of heat, and non-metals are typically poor conductors of heat. Now the next question is this. Josh notices that his feet feel warmer on the rug than on the ceramic tile floor. Why? Now take note that the assumption here is both of these, whether it is the rug or the tile floor, are in the same place. Therefore, they should be at the same temperature. They're in the same room. Therefore, this idea of higher temperature is straight away out. Now, when you look at a question like this, you must be aware of the concepts being tested. In this question, to solve this, to answer this, you've got to know three basic concepts. The first concept is heat flows from a place of higher temperature to a place of lower temperature until both reach the same temperature. And the second idea is a person will feel cooler when he or she loses heat. Or a person will feel warmer when he or she gains heat. Or he or she is surrounded by poor conductor of heat to slow down heat lost. Now, in the earlier example, he said his feet felt warmer on the place. Now, therefore, some of you may think that, therefore the rug has a higher temperature. But remember, I talked about the assumption that these two things, the rug and the ceramic tile floor, are in the same room. If that's the case, then both of these are at the same temperature, and this answer cannot be the answer. Now, let's take a look at the picture. Now, some of you may not know what's a rug. A rug is like a carpet, or think of it like a very thick towel. So when a person steps on the carpet or a rug, you will notice that there will be air spaces in between his feet and the bottom part of the rug. Now, earlier on we talked about heat flow as well. Now, the person is at a higher temperature compared to the surroundings, including the rug. Therefore, heat will flow from the feet to the surroundings. And since the fabric that is used to make the rug, as well as the air that are trapped in the air spaces here, are both poor conductors of heat, this will naturally slow the rate of heat loss. This idea is similar to you trying to keep yourself warm in a cold place. You don't want to lose so much heat to the cold surroundings, like you may be in a place that is snowing or in a really cold air-conditioned room. You will wrap yourself with something made of fabric that trap air in between the spaces of the fabric. That is meant to slow down the rate of heat lost from your body to your surrounding, so you feel warmer. It may even create a pocket or a layer of warm air around yourself because your body will heat up the air immediately next to your skin. So wearing a woolen jacket keeps you warm, not because the woolen jacket is hot, but because it simply slows down the heat that your body is losing. Get it? Great! Now let's take a look at the picture on the right. Now this feet here is touching the ceramic tile directly. Although ceramic is also a poor conductor of heat, but compared to the rug, where you not only have the fabric itself, which is a poor conductor, there's also air that's trapped in between here. Therefore, if your feet is on the rug, your feet will lose heat more slowly to the rug compared to your feet on the ceramic. So the answer is clearly rug is a better heat insulator. Although I prefer the term better, it's a poorer conductor of heat. Alright, and the reasoning is here. Since the rug is a poorer conductor of heat with the trapped air, compared to the ceramic tile, Jaws lost heat more slowly on the rug so that his feet felt warmer. Now, next question. Looks like a very simple question. Alex argued with Jenny that heat and temperature mean the same thing. So please help Jenny explain to Alex by listing one difference between heat and temperature. Now, if you've read your textbook, you have clearly seen this page about what heat is. Also, you have also seen things like temperature is a measure of how hot something is. So my point is, when you revise, read up your textbook and your workbook from your previous years. It really helps. And such questions could be so simple you think it will not come out in PSLE, and that you are wrong. This question came out in 2018, very recently. There are other questions that test you on basic concept. These are of basic processes. These are not commonly asked, but when they do so, you should grab it because they are giving you free marks, so long as you have read and understood and remember these basic ideas. Okay? Now, let's carry on. So what is this basic concept? Now, firstly, of course, you have read and remember, heat is simply a form of energy, and temperature is a measure of how hot or cold something is. So, help Jenny to explain. Heat is a form of energy, Alex. Temperature is not. Temperature is a measure of how hot or cold something is in degrees Celsius. So, temperature is not energy. Heat is a form of energy. Now, this next question is always know the direction of heat flow. Whenever you do heat question, you must know this. Where is the heat source? Where is the cooler surroundings? So for example, in this question, you are given two scenarios and you're supposed to find out what are the items that are losing heat and what are the items that are gaining heat. Before you can do this, let's zoom into this basic idea. Things that lose heat must naturally be at a higher temperature, must naturally be hotter, and things that will gain heat naturally must be cooler, alright, and must be at a lower temperature. That is how they can gain heat, because they have less to begin with. So let's take a look at this. Clearly, bowl of noodles is hot because you see all this hot mist that are escaping from the surface of this soup, evaporating. So the metal spoon, porcelain bowl are all in its surroundings. The hot noodles definitely is losing heat to the cooler metal spoon and the cooler porcelain bowl. Similarly, in this case here, it's slightly more tricky though. Iced tea, metal spoon. In this case here, the metal spoon will be the hotter surrounding because it was in room temperature at first. Just like the glass, also hotter. But how about the liquid here? The iced tea, which means the tea and the ice and the lemon are all the cooler objects here. Alright? And when that happens, it means that this will be gaining heat. So when you look at this, it is clear. The things that are hot will lose heat. Hot things lose heat. Cooler things gain heat. Cooler things gain heat. Again, let's recall the idea of knowing the direction of heat flow. So this is a hot milk at 60 degrees Celsius. There's a basin of cold water. So what happens to the temperature of the milk? If your answer is just it decreases, you will have gotten half of it correct. Okay, let's take a look at why. Now, hotter things will lose heat to the cooler things, and cooler things will gain heat from the hotter things. But when do they stop gaining and losing heat? It stops when the temperature drops to room temperature. Temperature of the milk will decrease all the way to the room temperature. That is when the cold water will gain heat all the way up to the room temperature. Eventually, both the cold water and the hot milk will just be at room temperature. Why? And this is based on this concept that's being tested in this question. Heat flow from the hot milk to its cooler surroundings until the temperature of the milk and the surrounding are the same. Alright, because it is not an indefinite amount of heat in the hot milk. There's a limit to how much heat you can lose. Now, on to the last questions we are doing now. Now, whenever you look at the question, again, think of the concept being tested here. In this case here, there are several concepts being tested. You see hot water, bottle, balloon. What will happen to the balloon when the bottle is placed in the basin of hot water? And you have done this before when you were in primary 4. Your teacher will have given you a bottle with a balloon stuffed over it and asked you to place it in some hot water. And if you have not, and if you are my student, come look for me and I will show you, I'll get you to do it. Alright? The concept tested here is matter in states, right? Whether it's solid state, liquid state, or gaseous state, will expand when they gain heat and contract when they lose heat. Now, take note that gases will expand a lot more and a lot faster compared to solids and liquids. That is why you do not see your parents' kettle or frying pan becomes big and expand just because they place it over the stove, right? So this basic concept here is matter expands when it gains heat. So firstly, what expands? Well, there's air inside, you must know. And the bottle, when it's placed inside this, the bottle gains heat from the hot water. The heat from the hot water will be conducted to the bottle, and then the bottle becomes hot. Next, the air in the bottle will gain heat from the hot bottle. So what will happen to the balloon when the bottle is placed? The balloon will inflate or will expand. Because as the air expands, it pushes in all directions. It cannot push the glass bottle until it expands, but it can push against a flexible balloon and make this expand or inflate. So the bottle gains heat from the hot water, the air in the bottle gains heat from the hot bottle and expands. I hope you have benefited from these few questions and explanation. All the best.